Hello. Welcome to this video in the Avis tutorial series. So we're going to be continuing our more complex use cases of the Avis API by looking at another ML workflow that could be useful for people and showing how Avis can be inserted into this machine learning workflow. Today we're going to be looking at how to take a video file and decompose it using a machine learning model into different shots. So it's a model that's going to detect for shot detection. It basically detects whenever the camera changes, and we're going to see how we can use that, take that data and create an interactive visualization of the result within Avis that we can browse at our leisure. So hopefully I will have put on the screen inserted a preview of how that's going, of what that's going to look like. We're going to be heading over to API and ML on the Avis API website, and we're going to find the link to the machine learning notebooks, as we have been doing in this tutorial series. And we are going to go and click on the ML workflow tutorials. So today we're looking at this second one in the distant viewing category. So as always, each of these notebooks is available both online and offline. So we can click straight onto the Google Colab version of this notebook, and we can do everything in there and it'll work fine. But I will be using the local version just because it's a bit quicker. So you can find the local version by clicking on it, and you can see where it's found. Oh no, sorry, that's the wrong one there. This is the one we're looking at. So we can find it here, and they're both basically exactly the same code, just with a few changes so that one works better on Colab and all that kind of stuff. So I've already gone ahead and cloned my repo onto my local machine and opened it up in VS Code. If you want help with that, then you can look at the first video in this series of API tutorials, which takes you through setting all that up. So to do this, we're going to go head over to the local folder. We're going to go over to workflows, distant viewing, video shot decomposition, and we're going to open the notebook up. So what are we going to be doing precisely in this notebook? So we will be getting a video that we have already stored on Arvest. And then we're going to use something called the distant viewing toolkit to detect shot changes in the video. So what's the distant viewing toolkit? It is a Python package that is created and maintained mainly by Taylor Arnold and Lauren Tilton, I believe, at the University of Richmond, which is basically a Python package which allows you with very little setup and it's very easily and simply to start using a number of distant viewing computer vision algorithms very easily. So I highly recommend it, and that is what we're going to be using today. So we're going to use their a model for shot detection to detect changes of shots in our video. And once that's done, we're going to be building an interactive IIIF manifest, which can be viewed directly in Arvest. So, we actually in VS Code that we want to be doing this. So I'm going to go ahead and press get my setup running. So it doesn't look very pretty, this cell, but it's pretty simple. Basically, I'm just having a clean install of the various packages that I'm going to need. Then I'm going to be importing things like the Avis API, the Avis tools, and other utility functions. The distant viewing toolkit, which is how we're going to be decomposing our video. IIIF Prezi 3, which is what we're going to use to to create our manifests, and also creating a temporary folder, which is where we're going to dump all of our temporary stuff that we will get as we need. So what's the first step going to be? Well, we're going to need a video to decompose. So for this, I mean, there's different ways that we could do this, but we're actually going to show an example of using a video that is already stored in our media on Arvest. So basically what we're going to do is we're first going to log on to Arvest and create an instance of this Arvest class using the Arvest API package. So I'm going to hit play on that. So hopefully you'll have seen how this works in previous tutorials. But we'll see that I'm connected with my account with the username JH. And then I'm going to find a video that I have already stored on Arvest. So if I come back to Arvest and I connect in my media, so I've got quite a lot of media going on at the moment, but I happen to know that the one that I want to look at is this one called Short Video with Many Shots. So it's a video that I found on YouTube that is a video with lots of different shots in it, so we can take a quick look if you like. So
this is going to be a fairly disappointing video. I am not inside a fusion reactor. I'm in an air.
I hope that this won't be a fairly disappointing video, but yeah, I will try and make it less loud when I edit this. But basically, yeah, I continue.
On top of a hill. I am squinting into the sun. I'm on the Swanscombe Peninsula. I am about to cross a road. I am putting myself at risk.
So I'm sure many of you know Tom Scott, who's a great YouTuber, and this is an example of what's basically a video that's very good for testing this kind of algorithm because it's got lots of different shots in it, basically. So I have linked to that on Arvest, and so that I can find it when I'm scripting, I've actually added a bit of metadata. I've added in the identifier field this metadata API tutorial content auto shot decomp. So that's just something so I can find it within my script. So we're going to do that. Basically how this works is I'm going to use the get medias function from the Arvest API, and I'm going to iterate through all my media, and if the identifier of the media is API tutorial content autoshot decomp, I'm going to add it to this list of media. So this is a list because this script is actually made so that you can process more than one video at once, but there'll only be one video in our list, but that's how it is. So here we go. And in fact, yeah, from henceforth, we'll just be treating the first video, I believe. So yeah, so we found our video with success, and what we're going to do after that is we're going to need to download the video in order to process it. So we have, I have this utility function from my personal connection, which allows you to download content from the internet onto your computer. So bear in mind this is a YouTube video. It will work. It should work with that. So the YouTube API does change from time to time, but it's this leans on a pretty stable Python package that takes care of that for you. So it should all work. So I'm going to go ahead and click play on that. Hopefully it shouldn't take too long, so it's not a massively long video. But yeah, this kind of process, unfortunately we are going to have to download things locally for things to work, because these algorithms are going to need direct access to the media and to be able to read it and put it into memory, all that kind of stuff. So I have downloaded it into the temporary folder, so I can open that up and just check that it's all working how it should be. So there is no sound, which I believe is just because it's playing in...
this is going to be a fairly disappointing video.
It's just a little quirk when it's playing in VS Code. The sound doesn't seem to be going for some reason, but there is sound. But we don't need sound for this algorithm anyway, but yeah. So we have downloaded our video that was hosted on Arvest to our computer, and we're ready to analyze it. So for this, we are going to use Distant Viewing Toolkit's Anno Shot Breaks class. This is what's happening here. So we're creating an instance of the ano shot brakes class here that we're putting into the ano brakes variable. And then basically we're just taking the local path of this video, which was got here, which we downloaded. And very simply, this class has a run function, which will put our brakes into this object here. And then we're just going to pass the results, because I believe the result is given back in frames. We're going to need to convert that into seconds, because that's what our manifest is going to understand. And even for us as humans, frames isn't the easiest thing to deal with. So we use Distant Viewing Toolkit's video info helper utility function to get the FPS, the frames per second, which will allow us to, so we've got the frame rate, and that will allow us to take a value in frames and translate it to seconds. And then for each break that we found in the video, we will convert it into seconds and then put it into this object here. So I'm going to run that. So it's not a very long video, so it shouldn't take too long to process. So you see this is coming from Distant Viewing Toolkit. It analyzes the frames in batches. Yeah, I will get back to you once that has finished processing. In fact, yeah, so that's finished processing already, so at least let me have a quick sip of coffee. So the analysis is complete, and we successfully found 23 shots within the video. So there are different ways that we could access that. Then we could print them out. We could use Python to decompose the video into sub videos. But what we're going to do is we're going to create an interactive manifest to view these results directly within Arvest. So how are we going to do that? So if you've been following these tutorials, you will recognize this media to manifest function. So we're basically just giving this video item that exists on Arvest, and we're going to create a manifest from it. So it's very simple, just one line of code that we can use. So that is that's done. And then after that, we're going to in order to make it interactive, we're going to add a certain number of annotations to it. So we shall get back to this section in just a second and why it's commented out. We'll see that in a sec. What we're going to do is we're going to basically, for each shot that we've detected, we're going to go through each of the shots. Here we're just printing out our progress. We're going to use the Arvest Tools add textual annotation function to add a new annotation to our manifest, so to this manifest, and the textual content of that annotation is going to be this HTML here. So you see that we can add things like strongs and emphases to make it to sort of control how the annotation looks. So we're saying shot number, which is going to be I+1 because we're enumerating through this list. And then we have a line break, and then we're actually going to print also the time in seconds of the shot. And then we're going to use that same data to set the time of our textual annotation as well. So this means that each annotation we're going to add is going to be linked to a certain time. So we're going to run that, and it's done already. And then we're going to upload this straight to Arvest so that we can see what's happening. So this is stuff that we'll already have seen as well. So we're first saving our manifest disk, then we're uploading it up to Arvest and changing some metadata, that kind of stuff. And then we'll be printing out the preview URL so we can open it straight from our script. So I press play on that, and here's our preview URL. You can go to that, and here we have our manifest that has been created. So if we wanted, we could also go to the manifests tab in our workspace and get to it from there, but we went straight to it. And now if I open up the annotations, you see that we've got a number of annotations here which all correspond to a different shot.
This is going to be a fairly disappointing video. I am not inside a fusion reactor. I'm in an
So we can see
on top of a hill.
the annotations going
I'm on the
past,
Swanscombe Peninsula. I am
and you
about
can
to
see
cross a road. I'm
that
putting myself
when each
at
one
risk
gets
of being
selected.
sued. I'm at a party. I'm in the small
Sorry, I'm
village
trying to
of Yelling.
speak at the same time as Tom Scott, and it's quite loud in my
I'm
ears.
in the English countryside near
But you can
Canterbury,
see
and
that
this...
indeed, yeah, let's pause that. Sorry, Tom Scott. But the different shots do indeed correspond to the different annotations, the different shots that were detected within the video. And if we want, we can actually use this to scrub within the video as well. Yeah, but that's just to show how we can use Arvest to directly be able to interact with the results of our analyses. Now, that's one way that we could configure this interactive interface. Another way that we would perhaps like to do that would be, for example, to have another page of our manifest which corresponds just to the first shot, and then another page which is just the second shot, another page which is just the third shot. Unfortunately, at the moment, this is not compatible with the way that IIIF works, which is the underlying standard that Arvest complies to, so that it can be interoperable with other projects. Basically, the problem is, so this is how the code would work, and it would all work apart from the critical thing. You cannot set the start time of a manifest's canvas in regard to the media that it's pointing to. You can change the length, you can make it stop before the end, but you can't make it start anywhere else other than the beginning. So this is something that we are communicating with IIIF about to implement and make part of the standard. But it isn't part of IIIF standard as it happens. But that is how you would do that if ever you wanted to add that functionality in the future. So to finish, we can clean up. We can remove our temporary folder here, and we shall also delete our manifest from here once we're done. So this is stuff that we've already seen, just using get manifests and then looking through our manifests to see if the metadata corresponds to the manifest that we wish to remove, which we then remove using that. So yeah, that is how to use how to decompose a video by using a shot detection algorithm, and then this is how we can view the results within Arvest directly. So I hope that was useful, and I will be happy to answer any questions that you may have, which you can ask in the comments below. And we shall also be putting a link to anything, to all the things you will need within the description of this video. So thank you very much for listening, and I shall see you next time.